4.1, number 2. Find the critical numbers of the function. Okay, we finished critical number last time. X minus 2. So we know to find the critical numbers, we just need to find the derivative first. And then we find it's either does not exist or it is 0. So that involves finding the derivative. Now we're exporting this, right? Derivative of the top, keep the bottom, minus derivative of the bottom, keep the top. And finally, we have something like this. Good so far? Number 1, will this ever be does not exist? That means some x you plug in, this one is undefined. Well, we have a fraction. The bottom can be 0. But then a second thought, x squared plus 8 is always positive. So no matter what, this will never happen. Okay. Then the only thing left is f prime x equals 0. If you have a fraction, it is 0. It's the same as setting the top to be 0. Hopefully my derivative is correct. Yeah, and then this is quadratic. Up to now, I think there's no shorter answer other than the quadratic formula. $48. Okay, if you want to simplify furthermore, it's something like this. Okay, so you should have two answers. 2 plus 2 square root of 3 and 2 minus. Or set. Okay. Sounds good. Critical points are just these two things. You'll need to check. At least you should take the derivative first. Depending on the numbers, sometimes it's easy. Sometimes it's ridiculous, especially for web work. Anything can happen. Other questions? All right. Last time we were talking about extreme values, max, min. Okay. We basically say there are 3 steps we need to do. Number 1, check if it's doable. It's called extreme value theorem. You check if it's continuous on a closed interval. If yes, proceed further. If no, stop here. Okay. Second, now we want to find the candidates. We have 2 possible candidates, the ending points and the critical points. Furthermore, for critical points, we have 2 situations, both looking at f prime x. Okay. We didn't say this will give us the maximum or minimum. We're just saying this may give us maximum and minimum. Okay. Number 3, we have all the candidates from number 2. We just compare them. Whoever is the biggest is the absolute maximum, and whoever is the smallest will be the minimum. Hopefully this logic is clear. Now, all we need to do is just try some example. Okay, so I will assign you 2 examples. You try it by yourself. Number 1. X plus 2 cosine x on the interval negative 2 pi to 2 pi. Number 2, y equals where is it? Y equals 3x to the 4 minus 4x to the cube on the interval negative 2, 3. Okay, try these 2. All right, for number 1. Okay. Check the initial value, check the extreme value theorem. It's continuous, it's a closed interval, so check. Find ending points, find the critical points. Derivative always exists. Equals 0, you solve it. In this interval, you find 4 points. Now with the ending points and the critical points, you just put them together and test every single one of them. It's a little bit harder to test which one is bigger, but keep in mind pi is almost 3. Right, so this one is almost like 8. This one's almost like -4. This one's almost like 0.5 plus 1.732, so roughly 2.2. Yeah, it doesn't really matter now. Which is -3.8, roughly. Okay, with all that thing in mind, this is the biggest. This is the smallest. So, answer. How to say? The answer is okay. This will be the value of the maximum. This is where it happened. Make sure you write your answer in this way. I think everything is easy except for, when you have 6 number, it's really hard to see. You have square root, you have pi, and somewhere. But with some analysis, you can do it. Dun, 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 dun. X equal to -2 pi, x equal to 2 pi. Okay, any questions regarding how to finish this problem? Looks good. All right, let's check what we just find by plotting. This is the graph. Actually, no surprise. This is y equals x plus 2 cosine x. 2 cosine x is a wave. Y equal x is a 45-degree line. You put them together, it's almost like a 45-degree wave going up. Okay. Now we have x equals -pi over 2 pi, and x equal to +2 pi. So it will be the function value between these two values, the blue line and the green line. Still okay? Now what do? We find ending points here and here. That's -2 pi and +2 pi. We find all the critical points. That happens at 5 pi over 6, pi over 6, -6 pi over 7 pi over 6, and -11 pi over 6. That will be our local minimum and the local maximum. If that is okay, we have a total of 6 points. we just compare all the values. We find, okay, negative 7 pi over 6 is the lowest. Okay. And this one here is the highest. So that's our absolute minimum and the absolute maximum. Sounds good? That's pretty nice. We don't even know what the function looks like. However, we were able to find the maximum and the minimum. Do we need more time on the second question, or have you guys already finished it? More time? Just click yes. Take your time. Let's finish the second one. This. The calculation is long. The procedure is quite simple. So in the exam, you can expect something reasonable. Like probably I won't be asked you to do the power of 4 or power of 5 or things like that with a 3 or 4. It will be something like quadratic or small numbers like 1, -1, and 0. Okay, this is for practice. So we try to make it a little bit spicy. Does everything look all right? Okay, let's check our graphs. Okay. Again, the procedure. We have an interval. We have a function which we don't know what it looks like. Now we know by drawing. We check the ending points, which is -2 and 3. Okay. Then we check, do we have any other local maximum and minimum? By setting the derivative to be 0, we find -1, 0, and 2. So we have a total of 5 points. After you have 5 points, all we need to do is just try to compare which one is bigger, which one is smaller. We find the biggest one is here on the very left with this 37 at -2. And this one has the minimum with a -27 at x equal to 2. Okay, so we have a maximum and minimum, absolute. Sounds good? All right, that's the whole story about maximum and minimum. From here, you can see it's a really easy procedure. The computation may be long depending on the original function, but really, the idea is quite simple. You only have 2 possibilities. Just test them all. Okay. Now, can you do something about it? Well, let's assume you go to the stock market. Let's take 1 month or something like that. Now, can you identify where the absolute maximum is? Well, you have several candidates, local maximum, local maximum, local maximum, things like that. But you do have an absolute maximum here. That means if you're lucky enough, okay, you should sell your stock at there, which is October 12th. Okay, similarly, where is your minimum? Well, you have some local minimums. You also have the ending points. For what I see here, probably the lowest one is going to be this, either this or the last one. Okay, I don't know which one. 27, 27. Okay, this will be the lowest. Then that's your absolute minimum. That means if you're buying stocks recently, you should buy it on September 29th. That will make your profit the best. 6 months, okay, a year. We definitely know what happened on March 23rd. So if you're lucky, and actually you will see the first one here. So that's the moment you figure out, well, am I just a local minimum or am I an absolute minimum already? Should I wait? Maybe there is something worse happening, which it did. Okay. If you're lucky enough, you bought here, then you made a huge chunk of money. You also almost got your money, I won't say double, but more than 50% for sure. Okay. If you just start buying in March 23rd and sell right now. A lot of my friends actually try to bet where the lowest is. I would say lack of imagination made them, a lot of them bought here. Okay, and then they lost a lot of money. And because they, again, a lack of imagination, they sold it here. So they lost a lot of money. But actually, if they just wait a little bit longer, the thing is going to go back. So that's a totally confusion between the absolute minimum and the local minimum. When you reach the local minimum, you always need to guess, is it going to get worse? Or actually, we just hit the bottom. Okay, is it absolute or local? Of course, for 5 years and a max, it's pretty easy to see. 2008, we have a minimum. Oh, that was really bad. 2020, yeah. Moreover, do you see exponential growth here? That means something bad is going to happen. Otherwise, your money grow exponentially. Nobody's going to like that. Nobody's going to be able to sustain that. So, yeah, every 10 years, you got a financial crisis. You know, we got 1998, the internet bubble, the 2008, which is the housing bubble. And according to the pattern, we should have something in 2018, but we didn't. So when is that thing going to come? That would be a very interesting question. Okay, so if you're buying stocks, some warning, bad things may happen. Okay, the second thing is housing price. Same thing here. Do you guys, do you guys pay attention to housing price recently? What do you think will happen during COVID? Will the house price go up or down? Okay, actually, the housing price goes up. Surprising or not surprising? People are supposed to be poor right now. A lot of people went over bankruptcy, but somehow the housing price is still staying really strong. I guess the problem is the reason is not many people are selling their house. Therefore, they don't want to change to a bigger house. They don't want because they don't want to buy a bigger house. Therefore, we have a short supply, but we do have a lot of demand. People cannot afford rent anymore. And yeah, sadly, a lot of people are raising their rent during this process because they have nowhere to go, which is really really bad behavior. But yeah, that's economics. I tried to find it. I couldn't do it anymore easily. But if you go on Zillow, actually, let's see, Zillow housing market of La Crosse. Let's see if I can find the graphs. Hopefully. Otherwise, I can find the image. Yeah, that's certainly not good. Yeah, it's hard to do the prediction because the data is pretty small, but just according to the graph here, you can see there is roughly like a local maximum here. I would say like at the beginning of 2020, and now the housing market is still going up. Oh, here we have something better. Okay, when to buy, when to sell. This is the best place, June 2012. Okay, that's the absolute minimum. And now the absolute maximum is it's still going up. Okay, everything in the green area is actually by prediction. One of my students actually did a Kaggle competition on this, try to predict the housing price for the next year. And he did pretty decent. But roughly the whole housing market is going up. So like we said, it's actually at the ending points for housing market. And it's still expanding. All right. Is everything clear on absolute maximum and minimum? So from here, you can see what's the hard part. The hard part is in real life, you don't know the function. You have no idea what the formula is. Okay, that's why Goldman Sachs and all the big financial institutes, they hire a lot of people to actually try to estimate what the original function is, because once you know that, you know when to buy, you know when to sell for sure. Okay, so whoever makes more money is purely depending on who has the better model of what's going on, who has a better estimation of the function going on right now. It's big money. That's why they hire probably hundreds of PhD to work for them. All right. Any questions before we move on? It's a very easy concept, but it's very, very useful. Okay. 4.2. This section is more conceptual. It's called the mean value theorem. Okay. Well, it's basically just one theorem. We first go over the theorem, talk about what it means. Then we go over a little bit why, the proof, roughly. And finally, we talk about what's the implication in calculus. Like, how does mean value theorem help us to do anything other than it's interesting? Okay. So this is what the theorem says. Let a function f satisfies, it is continuous on a closed interval AB, and it is differentiable AB. Then, okay, there exists a C in AB such that f prime C equals That's what mean value theorem says. Oh, you guys can't see my screen, can you? It's in the book. You really don't have to copy. What's more important is what does it mean? Okay. Well, number one, this is what it means. Suppose you have a function on an interval a and b. Of course, you have fa. Of course, you have fb. Okay. Once you know these 2 points, the starting and ending points, you already know what do you mean by fb minus fa divided by b minus a. And then you know that is nothing but just the slope of this thing here. Okay. Usually we call this the average value. For example, the average velocity is going to be the ending minus starting dividing by the time interval. Sounds good? That's the average. Okay. Of course, this is not your function. This only uses the information from the starting and ending point. Your function may very well look like this. Okay, anything weird. Okay. What this theorem says is no matter how you draw the function, as long as it's continuous and differentiable, there will always be a point, at least one point, such that if you draw the tangent line there, which is f prime c, right? If you draw the tangent line there, it will be the same as the straight line I just drew. Sounds good? Okay, and this will work regardless how you draw the function. The function may look like this, but then you can always find a point such that if you draw the tangent line there, it's exactly the same value as your average value. Kind of makes sense here? I mean, the graph makes sense, right? What does it really mean? We can say it in another way. That is, fx always, f prime x actually, always attains the average changing rate. Okay. For a real life example, let's just think about driving from La Crosse, okay, to Madison. Again, we know you start from 0, you end up at 120 miles. Okay, you start from 2 o'clock, you end at 4 o'clock. Sounds good? I didn't know how you drove, but what I know is just one thing. You drove 120 miles within 2 hours. Okay, that is going to be 60 miles per hour. Is that your velocity? No, that is just your average velocity. Sounds good? I have no idea how you drove. Maybe you just drove really fast. You beat the speed limit all the time. Or maybe you just drove really slow. But nonetheless, eventually, within 2 hours, you arrived at Madison. That's the only thing I know. Still okay? Then, according to mean value theorem, you were driving exactly at 60 miles per hour. I don't know when, but somewhere during 2 to 4. That's what mean value theorem says. Does it match your common sense? if your average is 60, then somewhere you're faster than 60 for sure, and somewhere you're slower than 60, right? But how can you go from slower to faster or faster to slower? You must be exactly 60 somewhere. Maybe more than once, but at least once. Okay? You cannot just drive all the way to Madison without driving at 60 miles per hour sometime. That's just not true. Make sense here? Think about it. What will happen if you never drive 60 miles per hour? Then you are either always above 60 or you're either always below 60, right? You could never go from above to below because then you need to pass 60. Okay, so you're either all above or all below. But if you're all above 60, your average will not be 60. Your average will be above 60 because every point is above 60. Make sense so far? So if I already know your average is 60, somewhere you just cross. For sure. Okay. Another interesting thing you can think about is actually if you go to court, you got a cop, okay? And he just said, well, you left La Crosse at 2 o'clock. And you drove to Chicago. You arrived there at 7 o'clock. That's the only two things I know. Sounds good? What's your average velocity? 80 miles per hour, which is beyond the speed limit. Still okay? Now this is what's going on. The cops just say, hey, you drove at 80 miles per hour sometime between 2 o'clock and 7 o'clock, so I'm going to issue a ticket for driving at 80. Your argument is you didn't catch me, right? I think if you said I did, when? Is it 2 o'clock? Is it 3 o'clock? Did I do it in Toma? Did I do it in Madison? Did I do it, I don't know, somewhere at the stop station or something? And then the cop can say, well, even though I didn't catch you, according to the mean value theorem, you were driving exactly at 80 sometime. Actually, you definitely drive above 80 sometime, but I'm just going to use 80 to accuse you for crime. Make sense so far? So how does the court work in America? I have no idea. I doubt it will work this way. Like you can use some deduction. You just say, hey, if you don't catch me, you don't catch me. Yeah. Even though you can get a picture of me leaving La Crosse and ending at Chicago using only 5 hours, but you still cannot accuse me because you didn't catch me. But if the judge has a math degree, you're definitely doomed. Okay, they're going to say, well, there's no doubt. Unless you can prove that your driving is not continuous. You teleport somewhere, or you just suddenly you're on rocket. Actually, if you're on rocket, you're even worse. Okay. Sounds good. That's what the mean value theorem says. Very easy to understand. Well, how to go over the proof carefully? We need to use something called Rolle's theorem. R-O-L-L-E. Okay. What does it say? Well, very similar. Let F satisfies. Actually, you know what? I can basically copy the two assumptions because they're exactly the same. If it's continuous and differentiable. Then a third condition is FA equals FB, which is in addition. Then F prime C equals 0 somewhere in AB. Okay, looks fancy. Let's draw it as we always do. So now you still have a function. This time you have FA here, you have FB here, but this time they're the same. All right. And you have a continuous function. Somehow it starts here, but ends here. Still okay? What the theorem says is, then somewhere you're flat. Guaranteed, somewhere you are just horizontal. That's what this means. Make sense here? Do you accept it? Well, if you accept this, You accept that. Can you see they're basically the same graph, except one is just rotated by horizontal? Okay, so they're both true or both false at the same time. Very easy to understand. I will skip the proof. It's in the book. It's really not important. I think everybody get what this means. Okay. Now think about a similar example as we did before. This means what? This means if you take a round trip, starting from La Crosse, you go all the way around and then you end up at La Crosse again, which means your FA equals FB in terms of displacement. Still okay? That means at somewhere your velocity is 0 because that's the changing rate of your distance, right? That means if you do a round trip, you have to stop somewhere. You cannot just like do a round trip without stopping. It's not possible. Sounds good? That's common sense. Okay, so round trip, you stop. Implies you stop somewhere. Of course, we're talking about driving in a straight line. Okay, otherwise you can actually circle around, take a U-turn. Okay, but we're talking about a straight line. You go on a straight line and somehow you go back. So it's like you're going east and then you're going west. Somewhere you definitely just stopped. Okay, you don't take a round trip. Not round trip. You don't take a U-turn like that. I would say that's all for today. Tomorrow we will talk about more applications here. Okay.